answer. So how do we do that? How do we do calculations to get the A answer? Please refer picture yang mana saya dah attach dia punya jawapan. Okay, that's how I try to refresh balik apa yang you dah belajar, apa yang you tak belajar, apa ataupun apa yang you dah involve dalam kita punya activity in this course. Okay, and referring to the lesson plan for this course, we are in week 3. This will be on the stress pass. So kalau tengok you boleh ambil nota daripada YouFuture. So ini adalah sebahagian daripada combinations note in the week 2 and also week 3. So what exactly is stress pass? Stress pass is a different way to present the strength of the soil in different space or in different coordinates. For example here, commonly lah ataupun bila you buat triaxial testing ke, most of the time kita akan plot more circle in the shear stress and normal stress coordinate system. However, it can be shows you in different way to represent the stress at the certain point using the stress path or using different coordinates such as T and S, or also you can use P and Q. Okay, what is exactly the stress path? A stress path is a line that connects series of points, each of which represent a successive stress state experienced by a soil. So, itu yang kita nak katakan kalau you and the maximum shear stress can be transformed in different stress space yang mana kita ambil nilai titik-titik tegasan maksimum dia tu pada setiap circle tu. Kemudian kalau you ada different axial stress value for sample 2 and then increasing the axial stress in the sample 3, for example here red blue and red color. So you get or determine the maximum shear stress for each more circle, and you connect points from the center of this circle sehinggalah yang to the last circles here. You ambil titik 1, titik 2, titik 3 untuk different samples here. You sambungkan titik tersebut yang itulah kita panggil dia sebagai tegasan, laluan tegasan ataupun jalan ataupun keadaan di mana stress path represent the history of the soil, sama ada soil tu mengalami over consolidated clay ataupun normal consolidated clay or under consolidated clay. So that's example kalau dia melibatkan clay. However, the stress path, the stress history can be in any type of soil, whether in sand ataupun in clay, in coarse granular or in the fine soil particles. Okay, what is a T and what is a S? So for simplicity, the T can be presented as a average to the diabatic stress, iaitu sigma V minus dengan sigma H. Sigma V also known as a axial stress, yang mana sigma 1, while sigma H horizontal stress can be known as a confining stress sigma 3. Itu adalah T, sebab sekarang ni kita nak tukar mouse kita dalam space yang berlainan, iaitu T dan juga S. Tapi untuk S pula is the mean of the stress between sigma V plus sigma H over 2. It's the average lah. So nanti you akan nampak in the next slide macam mana kita boleh hasilkan the stress path for different conditions subjected to loading or unloading, ataupun dalam keadaan drain or undrained conditions. When you heard about drain and undrained conditions, of course, lastly you will know you can have the path for effective stress dan juga total stress of the soil sample. So remember, in a way to get the strength of the soil, it can be presented in the Mohr circle dalam tau sigma coordinate, ataupun you can present it in a T dan juga S coordinate. So that's how we can see the actions or any stress subjected to the soil. Okay, the next one, how it is represented to explain what is T dan juga is S. Okay, when you have some samples and then the sample subjected to confining stress and then you add additional axial stress, During that times dia akan ada stages in the consolidations dan juga sharing stage. It's how the stresses change from the initial state to the final stress value. So in a way to present the changes in the stress, you can use the stress path. It is a successive states of stress which a test specimen or typical element in the field undergoes during loading or unloading conditions. So bila you tengok the typical conditions in the field represent the loading or unloading is when you have a geotechnical applications. For example, you kenakan strip footing. That is another way yang mana sampel dekat tapak tu dia dah mengalami increment, the increasing in the stress value. How about the unloading? Untuk you tengok on sites, the applications when you have some sort of activity, excavation activities. So during the excavation activities, you may see that the changes in stress from the beginning to the ending, maknanya pada keadaan asal tu nilai stress berapa. But contohnya pada keadaan what we call it here rest state. Bila rest state, the value of the stress, what is the sigma V and what is the sigma H. Later on, when you remove some of soil samples from the site, what will be the changes stress after and before? That's the stresses can be presented by using the sampling technique in triaxial test to represent the changes in stress before and after. Sama ada you present it dalam bentuk Morse circle ataupun you present it dalam bentuk stress path. So the stress path here can also show you the failure line ataupun kita panggil sebagai stress path failure line KF. So kat sini dia ada KF. Column failure envelope yang mana you ambil tangent kepada setiap circle tu, that is the Morse circle failure envelope. So what are differences bila you melihat mana, sebabnya macam saya beritahu lah, kalau you ada Morse circle ni boleh pindahkan dalam bentuk stress path dengan cara you dapatkan maksimum pada setiap tegasan untuk titik tersebut. Contoh tadi kalau you tengok the smaller circle here is a point A is the maximum stress A, and then for the second circle here you got a B is the maximum stress B. Kemudian C is the maximum stress C, sampel 3. Kemudian D is the maximum stress for D is here. And then you connect all these points from the sigma 3, A, B, C and D. So that's you can get one stress path. The stress path here can be presented as a single line as what you have in the B. Maknanya dalam graf kedua on the right side, this is how it shows to you macam mana satu successive Morse circle dipindahkan dalam bentuk stress path dengan certain angle. So kalau dalam kes ni, you hanya akan dapat dia punya laluan tegasan sajalah. You tak ada pun dia punya value of the sigma V, for example, effective sigma V. But this line can give to you sama ada dia represent for total stress path ataupun dia represent as a effective stress path. Okay, this is the conditions. As I said, when we want to see the changes in stress pada initial state ataupun after initial state, iaitu loading or unloading conditions. Bila you tengok loading and unloading condition, this is increment in the delta stress in the vertical directions or in the horizontal directions. So for this moment bila kita assume as a initial conditions, we can say that all the initial value is similar. For example here path A kita akan ada data in the sigma H, data in sigma V adalah benda yang sama. For this time dia punya failure line is a failure line angle is a 0. So when you look at to the stress path B dengan failure angle is a 18.4, this is how it's relate untuk dapatkan the slope of the gradient ataupun the slope of the failure line. Same goes to the path C, D, E and F. So what are differences E and F? Satu keadaan di mana you akan ada the delta sigma H negative and the sigma V is 0. And for the F here, you akan ada delta sigma H positif, delta sigma V negatif. So you boleh nampak lah kan dia punya conditions ni sama ada positif ataupun Negative. The conditions or the explanations here to telling you what is happening before and after you kenakan loading. So I like to ask, what do you understand from this slide? You want to give me answer? Siapa nak jawab? Apa yang you faham dengan slide ni? Aida Amira, what can you explain or what can you tell me what is the meaning on this slide here? Sebab saya rasa you all dah belajar soal mekanik, you all dah belajar geoteknik. Now it's an advanced subject daripada soal mekanik dengan geoteknik. So I think that this is the time yang I want to hear you punya understanding and explanations regarding to the topics, because what I want to tell you is this is the opportunity untuk awak deliver your punya thoughts, because saya rasa dapat 7 ni sepatutnya dah lebih confident lah untuk express your feelings or your understanding, your knowledge about this chapter ataupun about subtopics lah untuk setiap minggu. What do you understand? Aida Mira?
Yes, madam.
Okay.
About cell pressure.
Cell pressure? Okay, what do you about the cell pressure? So you have to clear antara pressure dengan stress is a different things. For example here, pressure ni bila dia kan kita nak explain the details about the stress ni dia ada some sort of the acting ataupun corresponding area di mana pressure tu bertindak, daya tu bertindak ke atas permukaan, dia menghasilkan tegasan. So tegasan dengan tekanan dia adalah different meaning. Sekejap. Okay, pressure. Okay, Aida, what is the pressure? Apa dia pressure?
Pressure when loading is applied on the soil. Depends on the conditions of the soil, whether it's saturated or not, I think.
Okay. Thank you for answer. Pressure ni bila you kenakan, kemudian apa yang dialami oleh some mass, we call it as a stress. So maknanya dia ada some cross sections di mana tekanan tu you kenakan, dia menghasilkan tegasan. So for these conditions, in presenting the definitions stress pulse in the field, you kena lihat kondisi di mana stress in the active ataupun passive or in the rest conditions. In the rest condition meaning that pada certain points of the specimen ataupun pada satu kedalaman stress at the A here, when you look at from the vertically ataupun horizontally, you akan nampak titik A ni dia mengalami tegasan in the all directions ataupun in the confining pressure dia. So the other problems that subjected to the soil mass here, dia mengalami effect of water table. So when you have the effect of water table, automatically in your mind is that finally you akan ada in the changes of stress due to the poor water pressure, atau dalam kata lain you kena dapatkan effective stresses untuk vertical directions and also in horizontal directions. in a way to calculate the stress sama ada rest condition active or passive, kita ada one coefficient iaitu kita panggil coefficient of the lateral earth pressure. So the coefficient of the earth pressure, kalau dia dalam keadaan rest, you can take the typical value 0.5 for normal consolidated clay, and also can be calculated if you have a different soil type, contohnya granular ataupun you ada OC clays, you tak tahu pun dia punya K not berapa, you are given the angle, for example silty clay kan, you ada dia punya angle berapa, so you can substitute here, you akan dapat the coefficient value. So the stress history dia berkait dengan stress pass. Maknanya kalau you tengok sini clay is not only is a clay itself, dia berubah bergantung kepada stresses subjected to itself, sama ada dalam keadaan normal consolidated clay, over consolidated clay ataupun under consolidated clay. So all these types of clay they give you different value of K naught. So please be careful when you are dealing with the soil problems. For example, kalau you ada consolidated, over consolidated clays dengan very dense sands, so we can take the value more than 1. So how it is present the stress pass for this stress conditions of the sample in the field. So dia tunjuk balik macam mana kita nak presentkan tegasan tu dalam bentuk laluan tegasan. Maknanya kita tadi ada stress point saja, kita ada effective sigma H, kita ada effective sigma V. Untuk dapatkan dia punya stress pass, you kena tahu the maximum shear stress T. So when you get the maximum shear stress ni kat sini di atas ataupun at the maximum stress value on curve ni, you ambil daripada sigma 3, you boleh gariskan satu garis lurus. So itulah yang mewakili stress pass dalam keadaan K naught or at the rest conditions. Apa yang berlaku bila you kenakan beban in the drain conditions? So tadi kita tengok kan awal-awal tu at rest conditions memang water table dah ada dekat ground surface. So bila you kenakan loadings, for example here street footing, you akan nampak the changes in the stresses and also the changes in the pore pressures. So for this case, let's say we assume that the horizontal stress or the confining stress sigma H remain constant. The changes only happen at the value of effective vertical stress. The effective vertical stress increase until the failure lines meet. Maknanya kalau you nampak you kenakan lagi tegasan, you kenakan lagi tegasan additional vertical stress increase until it fails. So that how you can produce the last pass line yang mana bila dia makin bertambah-tambah until dia meet to the last stress pass failure line. So KF ni mewakili stress pass failure line. Okay, the stress pass failure line dia tak sama dengan Moore column failure envelope. Macam saya tunjuk tadi lah, kalau Moore column failure envelope ni kita akan ambil daripada dia punya tangent of the curves setiap tu. So kita akan dapat parameter C dan juga V. Tapi kalau kata you plot untuk dapatkan tegasan pada setiap you nak dapatkan stress pass pada setiap Moore circle tu, dia akan ada satu final line for representing the stress pass. Yang ni you can see that now we are plotting the stress pass in the TS space. So kita bukan plot dalam tau dan juga sigma. So bila you plot dalam tau dengan sigma, you akan dapat Moore circle lah. And then kat situ you akan dapat Moore column failure envelope and you can get this V dan juga C. Tapi kalau you just plot dengan space T, S, so you akan dapatlah the only thing is that dia punya maximum shear stress connected with the another maximum shear stress to produce a straight line. Straight line tu adalah mewakili stress pass of the samples. Just now for loading conditions, this is for unloading conditions. The primary effect water table still there, but now is you having a excavations activity yang mana you excavate some soil element to the field depth. So you akan nampaklah bila berlakunya pengurangan dari segi kedalaman, of course tegasan pun akan berkurang. So what happened here is that kita akan nampak the decreasing in the effective vertical stress, and the sigma H remain constant. Right now it is subjected to the axial extension due to unloading. So the stress path for loading is shown as the green line. So element fails when it reach the KF line for extension. So kalau ikutkan just now, kalau kita ada loading conditions A ni akan heading forward lah. But now dia dalam keadaan unload, so A dia turn to the backward until it meet to the final stress path, final failure line of the stress path. Okay, how to present stress path? Tadi kita tengok conditions yang mana stress path can be seen with any application in the field, ataupun you nak tengok tegasan pada tapak. The same thing can be simulated ataupun can be observed through the experimental investigation using triaxial set apparatus. If you remember about the triaxial, kita akan ada this kind of the arrangement apparatus. You have the saturated salt, and then you apply confining stress, and then lastly you increase the axial stress sehinggalah conditions you allow drainage ataupun you not allow drainage. All those depending to kepada jenis triaxial test apa yang you nak buat. This one saya just refresh balik what's happening during the triaxial testing lah. Kalau kata you tengok dalam triaxial test during the experimental work, mostly kita conduct lah sampel yang mana you masukkan air, kemudian after sharing tu you keluarkan air, ataupun nanti air tu biar sampai habis eksperimen. So setiap proses tu dia mewakili jenis triaxial apa yang you conduct. But the thing need to remember in the triaxial, we have two important stages. Yang ni kita cerita about the triaxial compression, kita tak cerita pasal triaxial extensions. Kalau kata triaxial compressions, for the first stage is a sample is set in triaxial cell and confining pressure is applied. Maknanya dalam keadaan awal tu kita hanya kenakan sigma 3 saja. And during the second stage, so we apply additional axial stress, also known as a deviated stress, which induces shear stresses in the sample. So the axial stress is continuously increased until the samples fail. So first stage ni kita boleh call as a consolidations. Second stage ni kita boleh panggil shearing conditions. So during both the stages, the applied stress, axial strain, pore water pressure or change in sample volume can be measured. So kita boleh nampaklah berapa volumetric strain ataupun what is the pore water pressure, the changes in the pore water pressure. So I just highlighted three different types of triaxial test. Sama ada UU, CU dan juga CD. Yang ni lebih kepada refresh balik apa yang you dah pernah belajar dalam geoteknik dan juga soil mechanics. Okay, kat mana yang you allow drainage, kat mana yang drainage is not allowed. So kat mana berlakunya deviated stress increase, kat mana deviated stress remain constant. So the summary from that explanation, the differences between UU, CU dan CD, you can split into three main parameter variables, iaitu confining stress, and then deviated stress ataupun axial stress kat sini, and also the pore water pressure. Somehow kat sini dia put it as a sigma 1, or it also can be known as a delta stress. What is a delta stress? Delta stress is the difference between sigma 1 dan juga sigma 3. So that's why the previous explanation explain to you in which phase that stage yang mana confining stress constant ke, kat mana yang axial stress ataupun deviated stress increase. Kalau kata in initial explanation pun show you that how the deriving of the stress path created dengan keadaan bila you constantkan sigma 3, you increasekan confining stress or vertical stress. That is the process where you allow for shearing and then until the sample fail. So in this part also it tells you that kalau you tengok sini ketiga-tiga types of triaxial test, sigma 3 constants. Tapi yang berubah tu adalah sigma 1 dan juga pore water pressure. Sama ada dia dalam keadaan undrained condition ataupun dalam keadaan drained conditions. So for drained condition during the shearing stage ni, you akan buka drainage valve. Tapi you kena ingatlah dalam kes ni kita akan apply slow rate straining. Maknanya proses failure tu berlaku agak perlahan berbanding you kenakan sampel untuk triaxial consolidated undrained test. Okay, yang ni gradually increase from sigma 3. So very gradually increase from sigma 3. This is for sigma 1 untuk CU dan juga CD. Tapi untuk pore water pressure, CU no water permitted to escape, pore pressure measured for effective stress test, and CD untuk pore water pressure, drainage lines open. So kita akan dapatlah during this time untuk CD, later on you will see that ESP will be equal to the TSP. What is the ESP? Is the effective stress pass, TSP is the total stress pass. So the explanations about the wording just now can be presented in the chamber of sample triaxial. Contohnya, kalau you look at to the first one here in the initial conditions, this is the case yang mana fully consolidated dan juga sample dalam keadaan undrained. So apa yang berlaku kat sini adalah the sample is set in rises cell dan juga confining pressure is applied. So during this time kita nampaklah sigma H sama dengan sigma V, and the second stage in the shearing you akan nampak kalau you dalam keadaan triaxial compression, so there is a changes in the deviated stress ataupun axial stress. You apply sehinggalah sampel tu fail dan berlakunya shearing. Okay, what's happening after that? Bila you buat sampel dalam keadaan CU ataupun CD for fully saturated, there will be some generations of the pore pressure. Bila ada pore pressure generated from the samples, you akan ada two parameters kat sini adalah A dan juga parameter A dan juga parameter B. Parameter A, parameter B is deriving from the process in consolidations sebab dia melibatkan pore water pressure. So, apa yang you akan dapat from here is that the pore pressure parameters A and B is characterized the changes in pore pressure caused by the change in applied stress. So, bila you kenakan perubahan tegasan, you akan ada the effect is the changes in pore water pressure. Selalunya dia berlaku dalam consolidated undrained ataupun consolidated drained conditions. So, yang ni pun sama you boleh nampak in, for example, in undrained triaxial compression test, the cell confining pressure is applied in the first stage, the additional axial or deviated stress is applied in the second stage. The created first parameter here is a B. B ni adalah yang B terhasil daripada ratio of pore water pressure to the applied confining pressure. So bila you kaitkan dia punya relations from here is the changes in the pore pressure to the changes in the confining stress. So the B is also can be relate to the coefficients of CV dan juga CV. CC dan juga CV. CV is a volume of compressibility, CC is a compression index. Mana kita dapat CV dan CC bila dia you kenakan samples for saturated in consolidations. Contohnya you buat one dimensional consolidation test, you want to have the CV and CC, so the B can be found from here. So kalau kita nak relate balik dengan consolidations, it's back to the degree of saturations. So the degree of saturations will tells you the coefficients of the B. So the B also tells you, for example here, kalau kata fully saturated meaning that the degree of saturation is 100, so automatically the B is equal to 1. Kalau kita nampak kat sini, kita assume consolidations tu boleh berlaku dekat dalam tanah yang jenis fine soil. Kalau you ada combinations of different distributions of samples, ada sand, ada silt, ada fine and ada clay, so you kena buat testing and then somehow you kena buat consolidation test untuk dapatkan the exact B. So the B changes depending to the type of soil. When we talk about B, there's a connection also the pore water pressure dengan coefficients A. So the pore pressure coefficients of parameter A is defined as here. They can be relate antara changes in the pore pressure delta UD dengan changes in stress, deviated stress kat sini. So this one bila kita simplifykan balik antara B dan juga A, yang ni yang you akan dapat finally. Okay, this one same. Maknanya A pun dia ada kaitkan dengan pore water pressure. Kalau you want to see, A pun dia ada kait dengan consolidations. You nak tengok A untuk difference consolidation ratio, you can check from here. Somehow the value of B dengan A tu can be simplified dengan menggunakan typical data yang ada lah. Contoh kalau you ada very low sense, so A typical value at failure is a 2 to 3. Kalau you ada fully saturated dengan B is equal to 1, so you kena dapatkanlah what is the parameter A. Tapi kadang tu parameter A pun dia bergantung jugalah jenis testing ataupun jenis shear yang ada pada sampel. Sama ada linear elastic soil in the triaxial compression or in the plane strain ataupun in other elastic punya behavior of the sample. So these are the recommendations value for A. So B ni sama ada dia set as 1 ataupun dia give you different value of B. So what's important about B dengan A ataupun dengan stress pass adalah untuk deriving the formula. Contohnya kalau kat sini kita back to our discussions on the stress pass, the triaxial test stress pass in untrained for a linear elastic material. So andaikan you ada that total stress incremental parameter as what you have here, kemudian you ada effective stress incremental parameter, this is what you have, dengan set delta sigma 30, you can have the gradient or the ratio between delta T to delta S is equal to 1. Okay, bila kita kaitkan sampel dengan pore water pressure and then we know what is the B and we know what is the A, so you boleh dapatkan the deriving of the difference delta S dan juga delta T. So ini pun cara lain jugalah, you akan nampak delta T, delta S tak semestinya 1, tak semestinya 3 dan tak semestinya setengah. Dia bergantung kepada maklumat apa yang diberikan. So in other words, the total stress pass is a straight line with the gradient of 1. To obtain the effective stress pass, we need to consider excess pore pressure generations. So from the Scampton, setting B is a 1 due to fully saturated and the A is a 1/3 for elastic saturated material. So you take it the final equations here. Kat sini adalah this one is a B, here is a A. So nampak kat sini B kita sama dengan 1, kita punya A sama dengan 1/3. So dia dah substitute dalam formula ni sebabkan kenapa kita kena mula dengan delta U, sebab problemnya dia dah ada excess pore water pressure generations. So yang tadi tu dia tak bagi tahu apa-apa info berkaitan dengan pore water pressure generations. So bila you ada this problem, you substitute balik nilai B, nilai A, kemudian you susun balik formula. Dalam kes ni you akan dapat firstly delta sigma 1 kan. Kemudian you set delta sigma 1, delta sigma 3, dah dapat the final one, baru you jadikan nilai tegasan Mohr column tu kepada tegasan stress pass, iaitu delta T dan juga delta S. So the deriving of this formula I won't show that, you can have further reading. You boleh tengok closely macam mana dia boleh dapat from these informations. Kemudian how it is turned to the final ratio delta T to the delta S equal to 3. Yang penting tu dia ada maklumat gradient lah. Okay, yang ni explanation to the previous slide. This is one example how we can relate the stress changes from triaxial test untuk form to the stress pass. So the information given here, the isotropic consolidated to 100 kPa, they fail by increasing sigma 1 and sigma 3 such that delta sigma 3 is a 1/3 delta sigma 1. What is the final SF dan T at the failure state? The slope of the KF line is a 20 degree. So the solution is that first you take out dulu initial state, maklumat yang kita ada, initial state, initial consolidated S equal to 100 kPa is a mean stress. And then the diabatic stress T is a 0 during the shearing. Okay, yang ni maklumat ni dia bagi dekat soalan, you akan nampak kat sini. The delta sigma 3 sama dengan 1/3 delta sigma 1. So that is the also similar meaning to to the delta T. Yang ni adalah delta T juga. Delta T, kalau you tengok sini, delta T is a delta sigma 1 minus delta sigma 3 over 2 is a 1/3 delta sigma 1. So, delta S is a 2/3 daripada delta sigma 1. That in this part also, when you got the point, you boleh plot dalam T and S space. For this one, what we have from here is kita nak dapatkan what is the final S. Kita juga nak dapatkan what is the final T. T kat sini berapa nilai dia? TF ni kita tak tahu. SF ni pun kita tak tahu. Tapi kita boleh buat andaian daripada maklumat yang bagi, yang mana you akan hasilkan two different equations. For the first one, the initial conditions shows you the first equation yang mana T sama dengan S tangent 20 degree. So kalau you tengok sini, kita hanya ada S tangent 20. Meanwhile, for the second line, for the second equations, the angle of the slope, the angle of the slope for the second line is a half. So delta T over delta S. Maknanya yang ni yang berlaku selepas sharing. Yang ni line pertama tu initial conditions, line kedua tu selepas dia dah mengalami sharing state. Is the delta, the changes in delta T dan juga delta S. So apa yang kita ada from here, 0.5 is the angle, and then S is the unknown parameter yang kita nak dapatkan. Kita tahu the first isotropic stress consolidated is 100 here, or this one it can be substitute as a sigma 3 juga. So kita susun balik soalan, S minus 100 darab dengan 0.5. So the connection between line 2 and line 1 tu at this point kita boleh samakan dia satu persamaan sama dengan persamaan yang kedua. The final one, bila you susun balik these equations, you akan dapat the final S is 367.65 and the final T is 133.82. Yang ni you can substitute in any one equation yang you ada kat sini. The other part also tells you the coordinate, dan sebenarnya dalam T dan S space ni it tells you the coordinate of the stress point. So kosong tu representing the T, S representing the S. T kosong 100 is S. So kita mark dekat sini 100 S. Oh ni terbalik ni sebenarnya. Ini sepatutnya 100 dan juga kosong. So yang ni dalam keadaan T and S space. Kalau you ada problem in different space, contohnya dalam kita punya syllabus ni di cover T dan juga S space dan PQ space. PQ space tu saya akan explain kemudian. So on this part when you look at to this problem, CU kat sini dia tak mention pun whatever type, sama ada sand ataupun clay. It just give you one example. Kalau you ambil sample and then you conduct CU and you apply confining pressure sigma 3 is 600 kPa. Because this one is a undrained condition, and then the excess pore pressure is generated. So the things you're going to see that the rises from total stress pass to the effective stress pass, yang mana it can be related by one equation, ESP is equal to TSP minus delta UF. So by graphical, in the Mohr circle, let's say this is what you have for the first circle, 600. Kemudian 600 ni kita remain constant dalam initial conditions, and then bila stage number 2 iaitu sharing, you keep increasing the value of the deviated stress ataupun excess stress sehinggalah satu tahap tu all the excess water pressure tu you boleh count the numbers dia, berapa nilai dia. Kemudian bila dia dah reach to the final pore water pressure ni, in order to determine the effective stress path, you can take dia punya equations tu dengan pakai persamaan kat sini. You tahu what is the total stress path, you tolak dengan changes in pore water pressure, you akan dapat the point number pertama untuk ESP, point nombor kedua untuk ESP dan juga point nombor 3 daripada total stress pass. Maknanya kat sini you dapat point kat sini, you tolak dengan delta UF, you akan dapat this is the number ESP. And then when you connect all points from 1, 2, 3, red, green, blue, you sambungkan titik tu, you akan dapat satu lengkung garis lurus, backward lah. So this one is a forward, here is the backward. So you akan ada satu keadaan di mana the final stress pass line, the failure line of the stress pass. So this is indicate to you the KF line. KF line is a failure line of the stress pass. Yang dash line ni pula mewakili more column failure envelope. So the more column failure envelope is generated to you this effective feed. Meanwhile, daripada KF line, they can give you the effective alpha. So the effective alpha dengan effective phi ni can be related dengan satu angle ataupun satu equation iaitu sin effective phi equal to tangent effective alpha. So remember again kenapa kita kena belajar stress pass, sebab ada setengah complex problem of the determination shear strength in terms of you want to tell the behavior of the soil deformations. Dengan stress pass tu lah boleh ceritakan secara mendalam keadaan apa yang berlaku kepada sampel sebelum dia mengalami kegagalan. Okay, sekejap ya. Okay, sekejap kita break 5 minit. Okay, yang tadi berkaitan CU. Kalau kita nak ambil one of example from here, how to explain the conditions for CU isotropically consolidated, and then you have some value of the initial state and the final KF line. This is the conditions, the applications of the stress pass. In order to determine the value of the axial stress, when the effective stress pass intersect the KF line to cause shearing of the sample, assume the pore pressure parameter FLA AF is a 1. So this is a conditions yang mana kita diberi maklumat awal tegasan tu sigma 3, sigma 1 sama dengan 25, kemudian the final angle is a 30. In order to answer that one, first of all you have to take out dia punya informations, dapatkan dia punya coordinate dulu. So from here we can have that effective sigma 1 plus dengan effective sigma k over 2 0. This is the informations given to you, which here is the T, kat sini adalah S. So in the CU, tadi kita dah tengok one sample example CU dalam keadaan CU ni you akan nampak the increase in the deviated stress or in the axial stress, and it is turned from the total stress pass to the effective stress pass. Other than informations yang you ada kat sini yang mana stress tu started at 25 kPa. The parameter for pore pressure So when we plot on the ST space, yang ni pertama koordinat yang kita ada. Kemudian kita ada line representing total stress pass, and the changes from the total stress pass to the effective stress pass is given to you by the changes in the pore water pressure UF is equal to Q. Sekarang ni kita nak dapatkan the value of the Q. Q ni berapa nilai tegasan dia. The informations also give you that the final stress is a half over 2. Q bagi dengan 2. Kalau sini horizontally Q over 2, vertically pun Q over 2. Kat sini pun dia akan jadi Q over 2. So macam mana nak dapat remaining here is a 25 minus dengan Q over 2. Yang ni pun the same thing because kita nampak on the right side is Q over 2, left side pun Q over 2. So how do we get what is exactly the Q value? Q value ni adalah bila you susun balik dalam equations kita, the tangent 30 degree is a Q over 2, 25 over Q over 2. So tangent 30 is a 0.5774. So you substitute balik dalam this equation, Q sama dengan 18.3. So to get the axial stress, what is the axial stress? Axial stress, bila kita dapatkan axial stress efektif sigma 1 dengan so untuk dapatkan the total stress in the vertical, so kita akan tambah efektif sigma 1 plus dengan delta sigma V, which is just now we say that the vector stress is equal to 18.3 plus dengan our initial state conditions sigma 3 sama dengan sigma 1 is 25. So the final answer total stress or axial stress is equal to 43.3. Okay, dalam this part sigma 1 plus sigma 3, 25 ni, you have to see from here, 25 sigma 1 sama dengan sigma 3, 25. Kalau you susun balik dalam koordinat ni, sebenarnya 25 campur 25, 50 kan, 50 bagi 2, you akan dapat balik 25. So, what is the 25 from here is also from the initial informations given to you, the problem of the data in this question, sigma 1 adalah 25 kPa. So 25 kPa tambah dengan pore pressure, so you akan dapat the axial stress of the sample. So kita dah dapat lah efektif tadi, efektif 25 campur dengan total stress, campur dengan pore pressure, so you akan dapat total vertical stress. So yang ni pun sama, cumanya dia bagi keadaan tadi kalau kata it started at the origin lah. So you only have one single parameter sin alpha equal to tangent alpha as before. Tapi bila you ada some these conditions whereby you have the effective C and then effective A. So effective C ni you akan ada from the MC failure envelope. Whereby the effective A you akan dapat the coefficients from the KF line. So jangan salah ambil lah. Kalau kata you ada this kind of sample, you subjected to consolidated undrained, dalam case tu C bukan lagi kosong. So macam mana you nak dapatkan nilai C for shear strength of the soil? You can use this one. Okay, yang this is the problem showing to you conditions of the changes in parameter A, in the pore water pressure. So as I said here, the initially kalau kita tengok first one je kita akan dapat total stress pass as an input. Dalam case ni the parameter is 0. After the shearing, bila consolidation tu dah reach to 100%, the parameter A is equal to 1. So yang ni berlaku bila you ada conditions undrained. So bila you ada undrained ni, you akan nampak lah the effective ESP ni dia adalah satu kaitan yang mana ESP is equal to TSP plus dengan delta U, delta UF. Okay, tadi ni kalau you tengok ni dia boleh presented dalam T dan juga S or Q dan P spaces. Some convenient way of stresses can be stresses bergantung samples atau you ada triaxial sample space. So they will be having independent components of the stress and strain. So apa yang berlaku, macam mana stress, macam mana strain ni terhasil is due to the additional load that you kenakan. Bila ada tegasan tambahan mengakibatkan the in the deformation, that's how it is created to the strain. So the strain can be presented in the 2 dimensions or in the 3 dimensions, as well as in the asymmetric and triaxial spaces. So when you choose in a way to model your sample, for example using the computer modeling or simulations, you can choose whether the model geometry in isometric or triaxial space, in the 2D or in the 3D. Bila ada changes in the volume, they can be connected with the stiffness of the material and also the strength of the material. In a way to relate antara stiffness dengan strength material tu, kita akan menggunakan different parameters of the stress and strain. For example here, contohnya kalau kita belajar in the initial one, the stress is connected with normal stress is proportionally linear to the strain dengan satu parameter kita panggil sebagai yang modulus. So the deriving of this equation is coming up from here. Maknanya macam mana kita nak hubungkan tegasan juga terikan dalam spaces asymmetric dan juga triaxial space, you can use this one because the P and Q also stresses. Cumanya stresses yang presented in the space. Contohnya mean stress. This is the K as a bulk modulus, G is the shear modulus, because you want to see the changes in the volumetric strain. So kita pakai coefficients antara K dan juga G. In meanwhile, the Kg also can be related to 1 Poisson ratio nu. So ini dia tak tunjuk kat sini lah. So bila kita cerita about the changes, you can see the changes in the volumetric strain. You can see all the changes in the strain also. Okay, this is how it presented in different stress paths. Kalau you menggunakan what I want to say here, for example, shear stress T dan juga mean stress S, or it also can be presented in different space or paths, iaitu Q dan juga P. So remember back dalam kita punya syllabus, kita akan melihat stresses in the stress T, S dan juga Q dan P. So what makes different between Q dan juga P? Q dengan P ni is something that for this part you akan look at yang mana mean stress is vertical stress plus dengan horizontal stress. Ataupun they can note it as a sigma 1 campur dengan sigma 2 campur dengan sigma 3. So kalau you ada 3 tegasan, so meankan dia dengan 3. Kalau you ada 2 tegasan, you counter here in calculation, so dibagi dengan 2. So what are the difference is that bila Q and P space ni, the gradient of the KF line is by denoted the symbol M. M is defined from 6 sin effective P times dengan 3 minus sin effective. So bila you nak dapatkan berapa kecurunan, berapa sudut the KF line kat sini ni, untuk Q dan juga P space, you kena pakai these equations. Tapi kalau kata maklumat diberi dalam sebutan T dan juga S, so you couldn't use this formula. So the formula is not applicable anymore lah. So you kena pakai the appropriate equations ataupun get the right angle. Just now what we learned about stress paths in the CU. How about if you have a sample CD? In the previous slide, I'll show you the differences between CD for different variables sigma 1, sigma 3 dan juga pore water pressure. During the first stage, you apply consolidation ataupun you constantkan sigma 3, and after you kenakan shearing di mana axial stress increase or the deviated stress increase. So the important part is that in the drain condition, this is where you allow the drainage to occur in the slow rate of straining, and it is mobilized the drain strength from SDA and SDB. So the difference part here menunjukkan pada anda kalau kita buat comparison, we place next to next between CD and CU, you can see that the effective stress path for CU dan juga total stress path for CU will give you different stress path direction. Satu forward, satu lagi backward. ataupun you akan nampaklah some sort of curve. Tapi if you conduct the consolidated drain to determine the stress path of the samples failure, you can have that the conditions where the effective stress path is equal to the total stress path for the failure at A dan juga failure at B. Ini contoh kalau kata you ada point stress A, point stress B, the same thing is that sigma 3 constant, you hanya increasekan sigma V or the derivative stress. At one time, bila the more circle you reach to the failure envelope and also the stress path you meet to the failure lines, you akan nampak the line of the stress path for ESP dan juga TSP adalah satu line yang sama ataupun dalam laluan tegasan yang sama berbanding dengan CU. CU you akan nampak this is the right direction of the TSP, this is the direction for ESP. Here is ESP, here is TSP. The changes from the TSP to the ESP by having the pore water pressure as the final. Ini untuk CU. So whatever types of the sample, sama ada clay ke ataupun sand, you can have the same one. Okay, bila kita transform balik daripada Morse ke, you just want to see the stress path line only at stress at A dan juga stress at B point. The final one you can see that it is having one single line. For ESP, TSP line yang sama. Cuma dia punya gradient je lah berbezakan untuk representing point A dan juga point B. So the dashed line is a more circle failure envelope, and then the full line here is a final stress path line, failure line of the stress path. Also denoted the formula here untuk CD, the tangent alpha is equal to sin phi. So yang ni berbezalah untuk CU tadi. Okay, this is how it's explain to you untuk effective stress path drain shearing, the changes in stress from one point locations to another point locations until lastly it meets to the one single failure line here. Okay, this is the summary for what we have learned just now. So drain and undrained conditions, I'll leave it for you to read by yourself. Where the conditions that we can apply as a drain strength ataupun condition mana kita boleh apply sebagai undrained strength. This is another example. Okay, yang ni adalah summary lah kalau kita nak guna parameter phi untuk undrained dengan juga drain. Kalau you nak look at from here, they only tells you the value how it is can be relate antara effective overburden stress dan juga normal strength, normal consolidated clay strength, CU. So the typical one is proposed from the previous research by Bergeron and Scampton. So dalam case ni juga dia shows you that the consolidation settlement, IP, the influence line, immediate settlement kalau if you want to estimate the shear strength. But again, this is not the exact answer to be used the parameter value input tu. Kalau cara lain, you can another one kalau you need to estimate the undrained young modulus for problem in settlement ataupun compressibility analysis, you are given the CU, you can have this approximation formula. So vice versa lah, kalau you nak cari SU, you ada EU, so you boleh tunggang terbalikkan lah formula tu. Okay, yang ni pun benda yang sama, so take your time to read. Yang ni on the same part is only explain the major differences between undrained dan juga drained. Whatever soil types you have here, the only is the parameter. Kalau you tengok dia punya strength untuk clay, berapa nilai dia. Kalau you tengok undrained shear strength in order to produce dia punya stress pass, it's the same thing as I explained earlier. Dia akan produce satu straight line representing TSP and then backward curve line representing effective stress pass. So you tengok persen je kan, kalau kita tengok dia berbeza dengan clay, it's due to bila clay ni is a fully saturated. So bila kita conduct test dia, kita akan ambil dia dalam keadaan undrained shear strength lah. Tapi kalau you tengok untuk sand ni sebabkan the properties of the sand itself is a highly permeable. Dia boleh, air tu mengalir dengan senang. So you can conduct test under triaxial consolidated drain test. So consolidated drain test they produce to you one conditions yang mana ESP dan juga TSP in the same line of the failure ataupun in the same of the stress pass. Stress pass green ni mewakili point B, dan stress pass warna merah ni mewakili point A. Tapi kalau you nak tengok mana TSP, mana ESP, dia jatuh pada satu laluan tegasan yang sama. Okay, that's my explanation for this class untuk week 3. Another one that I want to explain about on the, sebabkan kita tak ada briefing for the first week punya sessions, just to remind everyone is that my teaching and learning approach under my supervisions. Different lecturer, different course, we have different approach. For your information also, kita akan ada satu pembelajaran yang mana kita panggil dia sebagai blended learning. Pembelajaran secara teradun yang mana for the first semester, half semester is online, maknanya remote learning. You ada di tempat you masing-masing, I will be at my locations. So kita learn through online. Ada some student dia dah back to campus in phase 1 or phase 2, but remaining from 1 to 7 week kita masih lagi menggunakan medium online Microsoft Teams. After in the ada face to face punya physical lah. So you going to attend the Makmal ICT dekat blok perdana 1.5. So kita akan belajar lah dekat situ bergantung kepada chapter dan juga topik. Kalau you tengok lesson plan tu, Praxis ni kita awalkan sikit, barulah kita letak chapter 3 dekat bahagian belakang. Kemudian apa yang penting, sekejap ya sekali lagi. Okay, yang penting selain daripada pengenalan yang berkaitan pendekatan untuk belajar 7 minggu pertama, 7 minggu terakhir tu, kalau you perasan juga kita punya kelas ni macam contoh hari ni Thursday, our timetable is a strict 3 hours. So saya dah decided the first 2 hours saya akan conduct online class lah. Bergantung kepada durations lah, sama ada it can be around 1 hour and 30 minutes ataupun lesser than that or almost 2 hours. So baki 1 jam lagi tu saya akan bagi you kebebasan lah untuk you menjawab learning activity. Dalam walaupun allocation in timetable 1 jam, if you want to do in the next day, okay. So the allocations you nak settlekan estimated dalam 1 jam je, tak lebih daripada tu sebab soalan pun tak banyak. Contohnya kalau you tengok kat sini, now we are in the chapter 1. So week 3, if you go here, for example, you are ready to take the activity, to participate the activity, you akan nampaklah the question appear to be answered. Okay, contohnya, okay, you click start now. So you nampaklah apa jenis soalan dia. Kemudian I encourage you to leave a comment, attach your solutions, attach your calculation documentations tu. Kemudian seterusnya week 2 pun buat balik aktiviti yang sama. The important part is that saya boleh track siapa yang ikut, siapa yang tak ikut. Contohnya, apa signifikan benda ni The significant is about as you remember kita punya regulations, academic regulations masih lagi guna pakai. Iaitu kalau kata you punya kehadiran less than 80%, I have right to ban or kata stop you from attending, from answering the final assessment. So final assessment tu kira kata yang final assessment ni around 60 marks kan. Kita punya continuous assessment, test campur dengan project, campur dengan quiz, lebih kurang tu. Saya check lah kat sini siapa student yang jawab and then dia punya percentage berapa, dan saya jumlahkan dia punya performance tu from here, attendance report. Attendance ni pun you kena careful lah because you are given a short time untuk you klik join ataupun you tak klik langsung. Bila you tak klik langsung tu maknanya you nak participate lah. For example here, kalau saya tengok overall attendance rate untuk certain group kat sini almost 61. Ada tu yang 33% saja. From the number here, I'll decide sama ada you allowing to have that final assessment ataupun tidak. It's very important for you and also your responsibility once you join the learning, the online class to the Microsoft Team, you kenalah klik dekat sini attendance ni. You pergi dekat manage schedule tu. Sorry, you pergi balik dekat online class. You masuk balik dekat sini manage schedule ni. You buka dekat sini, you klik lah hadir. So dekat situ dia bagi tempoh 15 minit sebelum kelas habis ataupun 15 minit selepas 15 minit selepas kelas habis. 15 minit jugalah untuk you jawab sebelum selepas, tak ingat saya macam mana. Tapi memang you kena klik. Kalau you tak tick kehadiran kat sini kan, makna kata dia akan affect percentage lah. Percentage ni nanti bila saya total up antara learning activities dengan online class tak cukup. So problem internet connections. So far, how many of you ada masalah untuk attend class secara online? So there is no forcing untuk you turn on the camera, but saya silakan. Cantiknya kalau kata you boleh join dengan answer the questions ke, join the activity ke, sebab tak adalah nampak macam apalah saya cakap. Okay, ada soalan tak? Any questions? So I have finished lecture in week 3. So the next week will be on the chapter 2. So memandangkan kita dah ada changes in the lesson plan, so we reschedule balik. Kalau you perasan chapter 1 dulu saya set ataupun the course coordinator has set chapter 1 selama 4 minggu. Due to some reasons, we have to adjust balik yang mana chapter 1 awak only 3 weeks, and if I'm not mistaken, your first common test assessment for CEG 612 will be on the 17th of November. Betul tak? You check balik my announcement kat sini. Saya dah letak latest announcement 15 hari bulan 11. 15 hari bulan 11. 8 hingga 10 malam. Common test. Untuk CEG 612, chapter 1 dan chapter 2 exclude more column model. So you kena bersedia daripada sekarang untuk jawab common test. Ambillah semua past year question, jawablah semua soalan dalam online course ni. Saya ada attach nota, saya ada letak problems. So take your time to have all those contents untuk you figure out what's important dalam this topic. Yang paling penting tu try lah dapatkan past year questions kan untuk this subject. Cari sini you boleh dapatkan nota dia. Get some overview lah about the course sebab nanti senang lah untuk you nak tempuh lagi few weeks left kan. So kita tak nak lah nanti last minute ada problem ataupun nanti you fail ke. So we try to plan our best in this semester. So any questions before I end our class?
Doktor.
Ya. Yeah.
Slide yang doktor tunjuk tadi tu doktor akan bagi ke?
Okay, I will update dalam YouFuture. Boleh?
Okay, thank you doktor.
Alright. Okay, dalam YouFuture tu saya tak letak yang saya update hari ni. Nanti saya update yang terkini. Any else?
Assalamualaikum.
Salam.
Doktor, yang learning activities tu dia masih close, tak dapat tekan. Yang hari tu je dapat.
On which part forum ke? Kalau forum memang saya ada set dia punya durations, course forum. Kalau learning activities, nanti saya check balik what is the problem sebab yesterday punya students class pun mention the same thing, yang mana dia tak boleh nak join. I'm not sure why lah, maybe I need to figure out balik. Saya dah set dah. Sekejap ya. Dia dah okay dah. Yang which week yang you tak dapat buat?
Dia tak ada langsung sudah.
Kalau kata forum memang saya dah tutup. Tapi untuk soalan biasa-biasa
soalan biasa-biasa tu tak ada, sudah hilang.
soalan biasa-biasa pun you tak appear pada awak
Ya madam, yang dekat learning activities.
Alamak, peliknya. Sekejap saya tunjuk yang saya punya screen. Ya, ni saya punya screen. Ni screen saya. Kalau ikutkan I'm afraid that you couldn't answer the learning activities is due to here, select group. So actually I have selected all group here. But then I'm not sure kenapa every time I select, every time I submit, every time I start, the thing is missing. I tak tahulah apa punca ni kan. So how to say maybe you can attach, you join kan dalam Microsoft Team kan? Kalau you join Microsoft Team, kat situ ada OneNote Classbook tau. Dalam OneNote Classbook tu, you boleh attach any answers or any activities. Maknanya you kena dapatkan soalan daripada grup lain ataupun yang mana ahli kawan-kawan awak yang boleh view dia soalan. So you attach dalam One Microsoft Team lah. Boleh tak? Siapa biasa guna One Microsoft Team? OneNote Microsoft Team. One Notebook. So dalam Microsoft Team ni, saya kan dah assign you group masing-masing kan. Contohnya kat sini Teams. Let me share against lah. So banyak sangat platform. So kita try and error or whatever things that suit you. Okay, contoh ni Microsoft Team kan. Contoh tadi you tak boleh nak attach ataupun you tak boleh nak join pun apa learning activity dalam YouFuture. Sebaiknya saya hanya nak gunakan satu platform je. So saya organize daripada YouFuture. You can view from that. Let's say if you couldn't answer from the YouFuture, you masuk dekat Teams ni under your group name ni. Kemudian you pergi dekat kelas notebook. Dekat kelas notebook ni, you can view dalam browser ataupun apps dekat situ you dekat sini nanti dia akan ada nama student masing-masing tau. So dekat nama tu you uploadkan lah you punya aktiviti apa yang you dah buat untuk minggu tersebut. Dalam ni saya tak tunjuk details lah sebab dia consuming time. Tapi once you join here, contohnya kan apa yang you nampak is a welcome to class notebook. So you open the class notebook ni in desktop ke ataupun browser. In other parts ni, I think that one sections on the left side is representing folder for each student. So senang lah, maknanya saya nak trace siapa yang hantar, siapa yang tak hantar kan. You can see on the right side, left side OneNote ni, start dia lambat sikit. Kat sini kan ada nama kan, nampak tak kat sini? Ada collaboration space, ada content library. That's why I said I try to manage one platform at UFuture sahaja. Tapi mana-mana students yang tak boleh nak join, I'm not sure what is the problem. I have contact the person in charge asking my question and waiting for their response to solve the issue. So sementara nak tunggu dia punya jawapan tu, every one of you can go to OneNote Classbook. To those who cannot submit lah dalam UFuture, you go here class notebook ni, find out your folder's name and then carilah nama contohnya Adrian. Adrian can place your attachment learning activities tu dekat homework for example. Okay, you letaklah week berapa. You type here, week 3. Apa tajuk dia, chapter 1, bla bla bla. And you attach lah. Kat situ saya tahu, okay, tak ada dekat UFuture, I know they will be here at OneNote Classbook. There's alternatively solutions that I can offer to you during this time. Selain daripada tu, saya try figure out kenapa UFuture tu masih lagi tak dekat. Ada soalan lain? Boleh tak?
Dah ada dekat UFuture, madam.
Apa dia?
Dah ada dekat UFuture.
Ya, itulah. You tahulah kan, saya bukan nak mengata tapi kan yelah UiTM punya sistem, dia punya users bukan worldwide, tak macam Microsoft, tak macam Google kan. So in a way to provide you good facilities, we have to be patient. So that's how I am very patient dengan UFuture from the beginning. Yelah saya dah banyak kali ni, semalam punya group student pun dah cakap benda yang sama. Saya dah tick, dia tak muncul lagi. Lepas tu group awak pun berlaku yang sama. Itulah I ask Nimika, saya nak cross check. Saya tak rasa you tak buat. Cumanya kalau ada masalah, let me know. Kalau you diam je, I tak tahu apa masalah. Okay? Alright, I think we stop here. So see you in the next class. Thank you. Wassalamualaikum.
Thank you, madam.
Thank you,
madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.